Hello, my name is Sarah Rabitoy.
Hey, I'm Michael Guillen.
Hi, I'm Burrell.
Hello, I'm Dagem Yohannes.
And we're Group 5, and our question is, how do spike shoes benefit performance in sprinters?
The question we have for y'all is, if you were a sprinter, which shoes would you wear to help enhance your performance? Take a minute to pause the video. Things to know about spikes. Spikes are beneficial because they are used for performance optimization. It increases the traction athletes have on a track surface, and it increases an athlete's ability to transmit force. This topic is essential to explore because it compares and contrasts the benefits of spikes for both sprinters and distance runners. Our research question is, why do spike shoes provide more benefit to sprinters than distance runners? Our hypothesis is spike shoes benefit track athletes' performance by increasing traction, improving velocity, and reducing injury.
Okay, so the article on this slide had the objective to find the difference between running shoes, spikes, and bare feet in sprinting performance within adolescent athletes. For this experiment, they found 33 athletes between the ages of 10 to 12 years old, with 19 boys and 14 girls participating. All of the adolescent athletes have had around 2 years of training experience and have been injury-free for at least 5 weeks. They will be sprinting 30 meters with their bare feet, running shoes, and spikes in random order to prevent any bias. Every participant will have the same warm-up, and there will be a standard 48-hour rest time in between each run to prevent fatigue from altering the experiment. A t-test will be used to measure sprinting performance, along with ANOVA tests being used to evaluate the finish times.
So, in our second article, their goal was to create a more efficient spike that decreased extrusion force and increased horizontal propulsion force, thus improving the overall mechanical performance of sprint shoes. So, they created a new bionic spike that was designed to have the geometric parameters of an ostrich foot toenail. Now, when comparing the conventional spikes, which have the basal diameter of 5 millimeters and the height of 7 millimeters, the bionic spike they created has a diameter of 5 millimeters, the height of 7 millimeters, a spiking slope angle of 13 degrees, and a groove radius of 7.3 millimeters. Now, what they did for the method was that a volunteer weighed 58 kilograms was hooked to a tensile test machine on a pressure plate that was able to record his extrusion force, his extrusion resistance, and horizontal proportion force. Now, the tensile test machine was set to 2 levels of speed, 25 and 250 millimeters per minute, and 2 levels of load, which was 0.85 and 1.275 kilograms. This test was repeated 3 times under each condition, and then the average was calculated.
Article 3 has a major significance because it can support that spike shoes are adequate when sprinting. In Article 3, it compared what the metatarsal phalange joint position does when sprinting in spike shoes. It does this by comparing spike shoes versus being barefoot while sprinting. This study used 8 highly competitive athletes, all having experience in the club level with experience in sprinting. There were 8 females and 5 males, all with an average age of being 22 years old. In the beginning, each subject had 2 duo X-ray scans. These scans were used as an aid for placing reflective markers on the metatarsal heads 1, 2, and 5, and bases 1 and 5. These markers' positions were placed on the subject's left foot. In total, there were 8 trials, 4 being barefoot and 4 being in the Nike spikes. Each subject ran in a 55-meter indoor track surface with a 5-minute rest period in between to avoid fatigue. While running in the 55-meter indoor track, a visual camera and 3D visual were taken on the left foot at 20 meters. Lastly, the predicted level of significance for this article is 5%.
For Article 4, this study compares how ground reaction force is influenced while running in running shoes, racing flats, and spikes in order to determine the performance benefits It consisted of 20 D1 distance runners, 10 males and 10 females. Subjects were required to be injury-free for at least 2 months prior and must have been participating in race-specific training for at least 3 weeks. A Kistler force plate was used for collecting the ground reaction force data. The peak vertical impact force, loading rate, peak braking and propulsion force is peak vertical force, stance time, and vertical stiffness from trials for both male and female were tested in all 3 footwears. Data for males and females were analyzed separately due to the difference in running speed.
In Article 5, it compared distance runners wearing marathon shoes versus track shoes. In the study, it used 24 distance runners, with 12 being male and 12 being female. Each subject had 3 visits in total. The first one measured that the subject was able to run under a certain lactate threshold. The second and third visit, the subject was measured with VO2 max, biomechanical stride characteristics such as flight time, and blood lactate concentration. During these 3 visits, each subject had a 15-minute warm-up, following a 4 to 5 minute run on the treadmill with different shoes at different speeds. There were 4 shoes in total, with 1 being spikes and the rest of the 3 being flat marathon shoes. It is also important to note that the highest speed of any of these subjects ran at 18 kilometers per hour, and the level of significance is 10%.
For the article about the adolescent athletes, the results found throughout the experiment were not significant. The boys and the girls had similar findings, as there was not much difference between the two. The average time sprinting with spikes was 5.28 seconds, 5.3 seconds with running shoes, and 5.31 seconds with only their bare feet. The results found that running with spikes was the best option out of the 3, as it created a slight benefit in sprinting performance. Below at the table, you could see the times that the boys ran each run versus the time that the girls ran each run. The table also expresses the 95% CI column, where it shows the range of times that the athletes finished the run. The experiment proved that there was only a slight benefit between the 3 trials, but at the professional level, these athletes are striving to be the fastest that they can possibly be. Every millisecond matters.
So the results of our second article was that the extrusion resistance encountered in the bionic spike is smaller, thus reducing the extra energy loss due to the extrusion resistance. And the bionic spike has a greater horizontal forward propulsion force, thus the better acceleration performance than the conventional spike. So due to this, the new bionic spike showed a greatly improved overall performance that gives a greater speed in a shorter amount of time. So what separates sprinting, what makes spikes more beneficial to sprinters and distance runners is the spike placement. So in general, the requirement is that 8 spikes have to be on the outsole. So the Article 2 came up with a design that considered the stress that is mainly distributed in the anterior part of the paw. They suggested 3 to 4 spikes should be laid in the big toe and the first and second metatarsal regions, with no spikes being laid at the heel or arc region. So in addition, a certain number of spikes should be placed on the 3rd and 4th toe and the metatarsal region, and in the 3rd toe to disperse the counteracting force of the runway and to protect the athlete's efficiency.
In Article 3, they used 8 total trials when comparing the Nike spikes versus being barefoot. The first thing that stood out is that sprinting shoes were significantly faster when comparing the sprinting shoe condition to the barefoot condition. The sprinting velocity was 0.3 meters per second faster with spikes. And it was also good to note that all subjects ran faster in spikes as opposed to being barefoot. The metatarsal joint range was also significantly reduced in sprint spikes, which had an average reduction of 9.2 degrees. This means that there is less energy required, which means that it can reduce injuries such as a strain. The joint moment also was found to be higher by 8.3 Newton meters, which means that it can be easier for an athlete to step forward while running. It was also found that when an athlete is wearing sprint spikes, their energy push-off bands will be greater. Overall, spike shoes can improve an athlete's performance by increasing sprinting velocity and reducing injury.
For Article 4, the data on the right proves that the ground reaction force experienced during running is significantly increased in competitive footwear compared to regular running shoes. Racing flats and spike shoes contain smaller heels, which may have increased the acceleration of the foot at impact. Competitive footwear expressed substantial differences in the larger peak vertical impact force, loading rate, stiffness for the spikes, and peak braking force. This may have been caused due to the difference in foot strike between the different types of footwear. The increased loading rate, stiffness, and peak vertical force demonstrate that running in spikes and racing flats produce a greater external load on the body.
In Article 5, it compared the biomechanical characteristics such as flight time when using marathon shoes versus spike shoes. It was found that in non-spike shoes, the running economy increased by 4.2%. And it also had a lower VO2 max found in distance runners when they were wearing non-spike shoes. One important finding is that spike shoes were found to be more efficient at higher velocities. It is important to note that in this study, most of the subjects ran about 18 kilometers per hour, but if the speeds were higher, such as an athletic sprinter running 24 kilometers an hour, the running economy would be better in spike shoes for sprinters.
With all of our data gathered from the 5 articles, they prove that spike shoes benefit track athletes' performance by increasing traction, improving velocity, and reducing injury. Increase in traction proportionally increases the ground reaction force and velocity. Spike placement towards the front of the foot benefits sprinters more than distance runners. Also, wearing spikes results in less energy production, which reduces fatigue and the risk of injury.
Our take-home message are that spike shoes are beneficial for both sprinters and distance runners. Stiffer and lightweight spikes are more essential for sprinters, and comfortability and flexibility are more essential for distance runners. And these are our references, and thank you so much for your time.